Hello everyone. We've known that the cell potential in Ecell is a measure of the overall tendency of the redox reaction to occur spontaneously. In our today's lesson, we are going to calculate the cell potential in Ecell. The objective is explain how the cell potential is calculated. Consider two water tanks with different water levels connected by a common pipe. The water in each tank has its own level and the corresponding potential energy. When the tanks are connected, water flows from the tank with the higher level, higher potential energy, to the tank with the lower water level, lower potential energy. Similarly, each half cell in an electrochemical cell has its own charge and the corresponding electrode potential. When the cells are connected, electrons flow from the electrode with more negative charge, greater potential energy, to the electrode with more positive charge, less potential energy. The standard cell potential in Ecell is the measured cell potential when the ion concentrations in the half cells are 1 molar. Any gas are at a pressure of 101 kilopascal and the temperature is 25 Celsius. The cell potential is the difference between the electrode potential for the cathode minus the electrode potential for the anode. So E naught cell equals E naught cathode minus E naught anode. Or E naught cell equals E naught reduction minus E naught oxidation. To calculate the cell potential in the zinc copper cell, we apply the formula. The cell potential E naught cell equals E naught reduction minus E naught oxidation, because the reduction occurs at the copper electrode and the oxidation occurs at the zinc electrode. So E naught cell equals E for copper minus E for zinc. By substituting by their values, the cell potential equals positive 0.342 volts minus 0.762 volts. So the cell potential is positive 1.10 volts. We can confirm our answer by the voltmeters reading in zinc copper electrode as it's measured 1.10 volts. Let's practice on what we have studied for today. The question is to determine the standard cell potential in Ecell for a galvanic cell that consists of gold and nickel half cells, and to identify the oxidizing and the reducing agents. The given here is the reduction reactions involved in this galvanic cell. For gold, the standard reduction electrode is positive 1.498 volts, and for nickel, the standard reduction electrode is negative 0.257 volts. Pay attention that galvanic cells have positive cell potentials and all the reduction reactions are reversible. The reaction at the anode will be the half reaction with the smaller or more negative standard reduction potential. So, we reverse the reaction at the anode to show the oxidation, but not its standard reduction potential. So it gives nickel that loses 2 electrons to form a nickel ion, and the reduction half reaction at the cathode, gold ion will gain 3 electrons to form gold atoms. The overall redox reaction, we use at least the most common factor, which is 6. So the overall reaction, the balanced one, is 3 nickel atoms plus 2 gold ions. That forms 3 nickel ions plus 2 gold atoms. To calculate the standard cell potential for this cell, we apply the formula E naught cell equals E naught reduction minus E naught oxidation. Then we substitute by their values. So the cell potential E naught cell equals positive 1.498 volts for gold minus 0.257 volts for nickel. So the value for the E naught cell is 1.755 volts. As it's shown, this is a spontaneous redox reaction. And because nickel is oxidized, so it's the reducing agent, and The gold ion is reduced, so this is the oxidizing agent. That was the end of our lesson for today. Thank you for listening.